Welcome to the Electrical and Electronic Engineering Lecture Series. The anchor person is Professor Michael Sindinechi. Our topic today remains Engineering Lecture Series, Self-Test, Part 6. Please follow me in the Engineering Lecture Series by subscribing to my YouTube channel, https://youtube.com/@NdinechiMichaelC. Like, share, and drop your comments in the comment section or reach out to me using my email addresses. To learn more about the topics that this self-test covers, go to my YouTube channel and check out Modules 023 Part 1 and 2 and Module 036. Thank you for being part of the Engineering Lecture Series. Like I said, in this lecture series, self-test is very necessary for one to evaluate him or herself, to know how much he has followed in the lecture, and will be able to answer questions if put across to him. So let's start. Question 1. Briefly describe the internet. The answer is, the internet is a large-scale public packet switching network that is operated by a group of carriers called the Internet Service Providers, otherwise known as the ISPs. Each carrier is known as a backbone. A backbone network is therefore a high-capacity packet switching network that uses high-performance routers and is interconnected by high-capacity transmission lines. As we go on, we will see more about routers and transmission lines used in internet operations. Question 2. With a sketch, show how different internet backbones are interconnected. So the backbone networks are interconnected at a number of special connection facilities called the network access points, NAPs, as shown in this figure. From our answer to question 1, we say that we have different carriers and each is known as a backbone. So if you look at the figure, you see backbone 1, backbone 2, backbone 3, and so on. And these backbones are interconnected using the network access points, NAPs, that we see, on top of the drawing. And if you look down, you can now see other things that access the internet. You have dialing users, you have the routers, you have the local area networks that connect to the backbones. So when they connect, let's say to backbone 1, if it is looking for an information and that information is not contained in the backbone 1, through the NAP, network access points, that request can be routed to another backbone so that it can look up for that information in that backbone. So as we look at that diagram, we see between backbone 1 and backbone 2, something like an electronic device, which we call the private peering. So if backbone 1 has sufficient community of interest with backbone 2, it will not have to go to backbone 2 through the network access point. It goes through to backbone 2 through that private peering because they have, high community of interest. So we say due to congestions in the network access points, most backbones are connected via private peering arrangements. Private peering is essentially network access points that are owned by the backbone operators and used to support one-to-one connections between backbone operators that have sufficient community of interest. Question 3 say, what are the two types of transmission services normally used in internet backbone routers? So the answer is there are two types. So the two types of transmission services normally used to interconnect backbone routers are: one, the private lines, which is usually a high capacity fiber based services operating at the 155 Mbps, otherwise known as the STM1, that is synchronous transport model 1. That is one form of, transmission services that, are offered by the backbone routers. Two is the asynchronous transfer mode, which are special high capacity packet technology that uses fixed length packet called cells. ATM services can typically support access rates up to 622 Mbps, megabits per second. Question 4. What are the typical features found in the Internet point of presence architecture? The Internet point of presence, architecture is a way through which Internet service providers, service their customers. So you say the ISPs maintain operating centers known as the point of presence around the world. A typical point of presence architecture is as shown and include the LAN switch. When we say LAN switch, the local area network switch. So all the components in the POP are connected through a high capacity LAN switch. Also has the backbone routers. So these backbone routers are very high capacity routers that connect to other point of presence or network access points. Normally, each backbone router will have a redundant hot standby. What do we mean by hot standby? For you to deliver highly efficient and reliable and system with high level of availability, you must have a parallel working channel. That is a channel that is always ready to take over from the one you are using in case there is any fault or breakdown. It will be so connected that you won't even notice when there is a change from one router to the other in case of fault in one of them. Because it is always there. In communications engineering, we term that hot standby or parallel working channel, that two of them are there, but one will be serving. Immediately there is a fault in one, the other one takes over. So we have been, meeting routers. Before we finish, we'll be able to define exactly what routers are and what they do in any communication system. So another thing you see in the, ISPs, POP are the access routers. So these are routers that support dedicated connections from customers. They channel traffic through the LAN switch to the backbone routers. You also have what is known as the remote access servers. These servers connect to the public switch telephone network and support dial-up customers. When we call a customer a dial-up customer, it means that, is a customer that, probably dials up on pay as you go basis. For instance, if you use your phone and just access internet, you are a dial-up customer. Then you also have servers, and these servers are the ones that support email or other network services and also connect to the LAN switch like the one we call the domain name server. For instance, in your university, if you have, email address that ends with your university.edu dot, your country, it means that you are operating a domain name server. So you also have the customer web servers. So say customers whose web servers are located at the ISP's POP, point of presence, will normally connect to the LAN switch on the 100 Mbps Ethernet interface. So this is a typical diagram that shows that you see the LAN switch, which is, at the center there. You see the access routers, which allows dedicated users to, get access to the LAN switch, and from the LAN switch through the backbone routers, they get to the, backbone to access information. Now down, you also see dial-in users that dial in through the public telephone network. For, us in this part of the world that make mainly use of, either GSM or any other handheld device to access the internet. We call such users the dial-in users, and they make use of the either the GSM network, which is, equivalent to the public telephone network, through the remote access servers to the LAN switch. From there, they get to the backbone routers to access information from the internet. Now, down here, you now see your email servers, see your DNS, the domain name server, and also you see your ISP. ISP means Internet Service Providers hosted customer servers. For instance, if your university is having a server, you have your, network, you have your website. Your server is hosted somewhere that you may not even be aware of, but you think that you are, just working with the cloud, that your information is being stored in the cloud. Yes, that is the impression you have, but you have a server somewhere that you are saving your data. So, question 5, how do consumers rent access to the internet from the backbone suppliers and resellers? So consumers can rent access to the internet using any of the following access options given below. One, we have what is known as the dedicated E1 or E3 service. This refers to the symmetrical digital private lines connecting a customer location to the ISP's point of presence at 2.048 Mbps and 34 Mbps respectively. So the E1, dedicated E1 gives you service at 2.048 Mbps and the dedicated A3 gives you at 34 Mbps respectively. So the second one is the dial-up modem. From the figure, we saw dedicated people, we saw dial-up people, and say one of the ways to get access is by using the dial-up modem. So this is the most prevalent access for residential and traveling users, which is asymmetrical in nature. The modem automatically selects the highest data rate which it can support based on the quality of the connection. At times, you use your phone, try to access the internet, you see, the quality may change from um, any of the fast internet, 4G, or it gets to 3G, and so on. So it is, you know, um, automatically trying to select the highest data rate it can support at that time. So the next one is known as the WiMAX wireless access. And this WiMAX means worldwide interoperability for microwave access. And it uses point to multipoint microwave radio transmission for its operation. WiMAX is the marketing name for products certified to comply with the IEEE 802.16 standard and supports data rates up to 1.5 Mbps. The fourth one is the cable modem. The more popular residential broadband option is cable modem service. This service is delivered over a coaxial cable used to deliver cable TV. The downstream channel operates on the unused 6 megahertz band. Then the fifth one is the ADSL, SDSL, which stands for the asymmetrical and symmetrical digital subscriber line, which operates over the copper telephone wire and delivers downstream rates up to 6 Mbps. Then you have the satellite access, so that direct broadcast satellite (DBS) providers offer satellite-based internet services, access services, but the service is slower. It comes at the 200 kbps to 400 kbps on the downstream link. It is rarely used except where there are no other high-speed options. So the good choice for it are rural areas where it will be difficult to lay cables for high-speed internet delivery, or due to some reasons, lack of other facilities, other services cannot get there. So you can use the satellite access to cover those areas. Then the seventh one is the wireless ISP known as the WISP. So operators of this WISP offer internet access to their registered subscribers using the IEEE 802.11, which is a standard otherwise known as the Wi-Fi, or some people call Wi-Fi, wireless local area network technology in public locations, and these are called hotspots. So anywhere, probably you are in a building, you are in a hotel, and you talk of hotspots, you know that what you are making use of is the WISP, the wireless ISP, which is the IEEE 802.11 standard. So this wireless access point is usually connected to the internet on the E1 or similar speed connections. We have talked about E1, which is 2.048 Mbps. Then the other, which we call the broadband access, is the 2.5, 3G, LTE, and 5G wireless access. Some people call this LTE the 4G. LTE stands for long-term evolution. So these are services introduced by the cellular carriers to deliver high-speed data services over their existing infrastructure that can be used to access the internet or corporate applications like the email. Users can access the services from their cell phones, personal digital assemblies, PDAs, and wireless modem cards installed in their laptops. Question 6. What do you understand by Uniform Resource Locator, URL, domain name server, and cookies? These are common terms you meet in your internet, balance. Here, URL, domain name server, and cookies. So as people who are conversant with internet, it's good you know exactly what these things mean when you hear them. So the answer is every device connected to the internet has a unique internet protocol address. That's IP address. This IP address is a 32-bit binary number usually written as a series of 4 decimal numbers using the format this dot this dot this dot that. This number we gave is just a fake number because it says 32 bits. So for convenience, the World Wide Web uses familiar names called uniform resources locators that are preceded by the letter www and followed by a domain name such as .com, which means is for commercial entities, .gov for government organizations, .edu for education establishments, .org for non-profit organizations, and .net for network operators. If you look at the first slide here, you will see my email that says michael.ndinechi at futo.edu.ng, meaning that my email is dedicated to education establishment, and NG means Nigeria, and the name of the university. So likewise, other organizations also have their own extensions or domain name. So the domain name server say when a user enters the URL on the browser's command. When we say your browser's command, if you start your laptop at the top, you see where it's giving you to enter what address you want. So that is called the browser's command. So when a user enters the URL on that browser's command line, a request is sent to a domain name server that looks up the URL in a table and returns the IP address. These DNS are arranged in a hierarchy. So if the local DNS does not have the address, it forwards it to the next DNS in the hierarchy. So at the top of this hierarchy sits the servers that are known as the root servers. And these root servers are the ones that connect one backbone to another. So cookies. In fact, sometimes you start your system, it will ask you whether you want to enable cookies. So what are these cookies? Say the web server can also request for short files called cookies that provide information such as other websites or pages the user has requested. In that way, even though each page requested involves a separate TCP connection to the web server, the user will have the impression that they are involved in one uninterrupted conversation. One uninterrupted conversation. Sorry for that. Now, question 7. What is VPN? What do you understand by remote access dialog VPNs? So VPN stands for Virtual Private Network, which is the secure and reliable services for enterprise applications of the internet. Keywords: enterprise applications of the internet, which could mean the commercial applications of the internet. Now, the remote access or dial-up VPN support secure dial-up connections and are used for accessing local area network-based resources remotely. Users access an ISP's network using a local flat rate access. Security is a major concern here since dial-up systems are susceptible to hacking. Therefore, in remote access dial-up, authentication and privacy issues are taken very importantly. Now, what is the function of this authentication server and VPN client software in remote access dial-up VPNs? One, the authentication server is the server that confirms the username and the password before access is granted. Then the virtual private network client software, the remote user device will require special software that is provided with the firewall server. The VPN client software and the firewall server together create an encrypted connection to ensure privacy. The privacy of the information forwarded through the internet once the user is authenticated is of importance. At the corporate data center, a firewall server unwraps the packet, decrypts the content before passing the information onto the LAN. See, what we said has two things. Authentication has to authenticate who is this person using his password. Then after that, it tries to now secure the information that is going to that person. So question 9, now, what do you understand by dedicated VPN? Remember, we talked the VPN as remote access dial-up and the dedicated VPN. And here we have seen what remote dial-up system is. We now want to see what the dedicated VPN is. So, since a dedicated VPN is an internet-based service that provides some level of performance guarantees. Very important. The dedicated one provides some level of performance guarantees. That is, when you use it, you are sure that it's going to give you some level of performance. So, to provide dedicated VPN services with performance guarantees, most ISPs use IP-based protocol called the MPLS, that is the multi-protocol label switching. This MPLS adds two important elements to the traditional internet protocol. The first one is virtual circuit. I say that unlike the traditional connectionless IPs, here all the packets for a particular session are routed on a virtual circuit. That is, it is assumed that there is direct connection between the point the information is originating from or data is coming from to the point where it is being delivered. Now, it is virtual in the sense that immediately that data is delivered, the connection elapses. It is not like when you now use a wired system to wire from one point to the other. That is why it is called a virtual circuit. Now, the MPLS calls this label switched part. At the time it is acting, that part is labeled. After that, it disconnects. So it also does capacity reservation. For the dedicated VPN, there is what we call the capacity reservation. So say before this MPLS, we allow a label switch path to be established. It will ensure that there is sufficient capacity available to meet the requirements of the connection. For instance, if the capacity available at that time is for 10 Mbps, and the data you are looking to carry is 20 Mbps, the system will not connect in the first instance, because if it connects, you will not be able to deliver the 20 Mbps. So say it must reserve enough capacity to carry that quantity of data you are looking at before it can establish that part. So it said before MPLS will allow a label switch part to be established, it will ensure that there is sufficient capacity available to meet the requirements of the connection. This standard approach is called secure tunnel. So he sees it as a tunnel that is big enough to carry the data that it is, it wants to deliver. So this standard approach, we say, is called the secure tunnel. So in this approach, the user's data is encrypted with the VPN client software installed in the user's PC before being sent. So question 10, what is the major difference between this dial-up now and the dedicated VPN? Answer is there's one major difference between the two, and that is that the MPLS in the dedicated VPN eliminates the need for encryption and a secure tunnel. That is, the MPLS defines the path over which each user's packet will be sent, and this helps the ISPs to provide VPN services that offer worst-case parameters for packet loss and delay. Because if he has established a path, it means that nothing can interfere with this path. So the worst case, he must be able to send this data, except there are some, things like losses and delays due to some other circumstances. So the networks will then not deliver the type of consistent delay found in the traditional circuit switch voice services associated with the dial-up. Like we said, because he has established a secure from one point to the other. So what will cause the delay? There is no delay. Then, even though performance guarantees vary from backbone to backbone, typical values will be that you have now packet loss of less than 1%, which is acceptable. Then you have the round trip delay of less than 70 milliseconds, which is also very, very acceptable. And above all, you have an availability of better than 99.99%. And we have said that when in your telecommunication parlance, you have an availability of 4 nines, it means that you are having, blackout of less than 1 minute in a day. So for every communication systems, the availability of 4 nines, that is 99.99%, is very much acceptable. So one major limitation in VPN service is that guarantees only cover traffic that stays within that provider's backbone. In other words, immediately your traffic is going from one backbone to the other, guarantees can no longer be guaranteed, because from what we said at the beginning, each service provider or each backbone engineers its own, technology. So if packet is coming from one technology to the other, then no person is guaranteeing what happened. So we say that it's a major limitation, because immediately your data leaves one backbone to go to the other one, then performance guarantees can no longer be guaranteed. Now, 11, what is the difference between circuit switching and packet switching? In a circuit switching network, a fixed portion of transmission capacity is assigned to a pair of users for the duration of a call. The basic model for circuit switching is the public telephone network. If you take your telephone handset, the landline, you see that immediately you connect to the other person, there is that circuit is fixed between two of you. We call it circuit switching. Now, the basic idea of packet switching is to send traffic in a series of addressed packets forwarded over a virtual circuit. I've tried to explain what a virtual circuit is. So, for packet switching, these packets, we have the address of where it is going. The data sent in the packet switching network has the information of the address where it is going appended to it. So when that is done, you see that all the packets will continue to go to the destined address in a particular route, as if there is a circuit connecting the two points, which we call the virtual circuit, because in real sense, there is no circuit connecting the two points. So some packet technologies like the IP forgo the virtual circuit and simply let the packets find their way to the destination. That is what we call the connectionless datagram service. We will explain this datagram service later. But now, when the packets with data, with address information are being sent, they are left to find their way to their destination because there is no virtual circuit. And that is how the internet protocol, known as IP, works. And that is why at times when you are receiving information, the system will be, at times it will fail. It will require you to refresh. When you refresh, then the data can come from any other angle. So it is connectionless. The network capacity is not tied up for a single user, but allocated dynamically to anyone who has traffic to send at that moment. This obvious advantage of packet switching is also good for its efficiency. So in packet switching, the potential traffic load is far greater than the actual network capacity. In other words, it can, support over subscription, and all users vie for same limited transmission resources. In other words, if many users try to send at the same time, some will have to wait. So those ones waiting, what happens? The packet switching therefore incorporates what is known as the traffic buffers. The expectation is before now you have met what a buffer is, where data is stored temporarily before being used. So say packet switching therefore incorporates traffic buffers. So if there is a momentary burst of activity, the excess is stored in the buffer and sent as soon as possible. The buffers increase the overall delay in packet switching. Packet switching technologies, of course, include the frame relay and the asynchronous transfer mode, which we have met earlier. So, a datagram, it's important for you to know this, is a one-way, unacknowledged packet that is forwarded without first establishing a connection. Any one way. So whether it fell or it doesn't fail, Whether it is delivered or not delivered, it doesn't matter to the protocol. And that is why we say that in the traditional IP, Internet Protocol, what happens is best effort. It is making the best effort to deliver. But if it doesn't deliver, it doesn't matter because it doesn't have time to acknowledge from you whether what you wanted is delivered to you or not. We call such, delivery data grab. It's a one-way, unacknowledged packet that is forwarded without first establishing a connection. Question 12. So what do you understand by the term ATM? The term ATM stands for asynchronous transfer mode, which is a switching technique used by telecommunication networks to encode data into small fixed size cells for transmission. It makes use of the asynchronous time division multiplexing technique. Please, I will refer you to model 034 in my channel to read more about the asynchronous time division multiplexing technique. ATM is the core protocol used over the SONET and the ISDI. It was designed to support diverse types of traffic, including voice, video, and data, with the use of virtual circuits for connection-oriented communication. ATM is very significant in networking and on the early development of high-speed internet infrastructure. So, question 13, what are the core principles of this ATM? ATM operates on two core principles, which include one, the cell-based switching. This is based on the cell-based switching is based on cell switching technique that includes reducing or breaking data down into fixed size cells of 53 bytes each. You know what a byte is? A group of 8 bits is called a byte. So if you now have 53 bytes, it means that you are having 53 groups of 8 bits each. So due to these specific fixed cell sizes, the data handling and transmission is more efficient and predictable. Two is the virtual circuit. ATM also provides virtual circuits which are created as required. ATM found diverse applications across various networking environments, leveraging on its unique characteristics to address specific communication needs. Question 14. Now, list the notable applications of ATM you know. Say that some of them include telecommunication networks, that is its ability to handle efficiently different types of traffic, including voice, video, and data, contributed to its widespread adoption in telecommunications infrastructure because most telecoms infrastructure carries voice, video, and data. Then high-speed data transmission. ATM's fixed-size cell structure and hardware-based switching made it very suited for high-speed data transfers. Also, the adaptation layer in ATM allow for seamless integration of multimedia applications. It is also used extensively in the virtual private networks. So ATM connection-oriented nature made it suitable for establishing virtual technologies in the networking landscape. What do we mean by that? There are disruptive technologies that are trying to disrupt this ATM signals. So I think for now we have to, stop here. We have lost our internet services. But yeah, we can continue. How many questions left? We can, quickly complete the, as my viewers are no longer seeing the slides. So we can complete our lectures. Question 15. How about two more questions to go? So differentiate between routers and switches. A router is a networking device that operates at the network layer, which is layer 3 of the open system interconnect, which is known as the OSI model. Its primary function is to format data packets between different computer networks, making decisions based on network address. A switch is a networking device that functions of the data link on the data link layer 2 of the OSI model. Its main role is to connect devices within the same LAN and manage the flow of data between them. It is good for you to pick two major differences here. The router operates in layer 3, while the switch operates in layer 2. And the router connects different computers or different networks, while the switch controls only connection in a particular network, local network. So quickly in a tabular form, we can see that between router and switches, their function, the router forward data packets between different networks. The switch does same within the same network based on the MAC address. By MAC, we mean the media access control address. The scope of operation, the router connects multiple networks for communication and direct traffic between different subnets or networks, whereas switch operates within a single network or subnet and connect devices within the same network. Addressing, routers use IP addressing for routing decisions, while switches use media access control address to forward frames within the same network. Broadcast handling, routers in the segment broadcast domains, which reduce unnecessary broadcast, then switches the forward broadcast packet within the same network. Topology, for routers, they are used in hierarchical or mesh network topologies. For switches, they are used in star or extended star topologies for same network devices. So you can see the differences. 16, so give any 5 standards of IEEE 802.11 you know and their features. So importantly, this IEEE 802.11 is commonly referred to as the Wi-Fi or Wi-Fi, as some people call, and is a set of standards for implementing the wireless local area network communications. It was established by the IEEE, that is Institute of Electrical and Electronic Engineers. It defines the protocols and technologies for wireless communication between devices, allowing them to connect to a local network and access the internet wirelessly. So there are, so many standards of them. We expect you to know these standards and what they stand for. For instance, the 802.11a uses radio frequency in the 5 gigahertz band and supports data rates up to 54 Mbps, but drops as low as 6 Mbps as the device moves further away from the access point. This standard uses the same base protocol as the original 802.11 standard, but makes use of OFDM, orthogonal frequency division multiplexing, which we can also see in my lectures on model 026. It has major shortcomings in that the price is way more expensive than the others. So we have another one which we call the IEEE 802.11b, and say that this standard operates in the 2.4 gigahertz frequency band. It provides data rates up to 11 Mbps using the CCK, the complementary code keying technique, as its modulation scheme. It uses a channel bandwidth of 22 megahertz, which allows for the three non-overlapping channels in the 2.4 gigahertz band. While 802.11a is stable for applications requiring high bandwidth in businesses and enterprises, the 802.11b is widely adopted in homes and small business environments due to its affordability in hardware. So you have the 802.11c, which is an amendment of the 802.ID media access control bridging standard to incorporate bridges in wireless bridges and access points. We talked about routers and switches. There are also technologies that are called bridges, which we didn't treat here. This work is now, still ongoing. We have this, storage, the 802.11c is, still evolving. We have the 802.11d. We have the 802.11a. We have the 802.11f, 802.11h. So it's left for you to look at these standards and know what each one of them is doing. If you are a communications person, people will not be telling you about Wi-Fi. They will be telling you about these standards, and it's expected that you know what the standards stand for. For instance, the 802.11i we say that it is the enhancement of the 802.11d, which is the media access control protocol that provides improved privacy. The security standard of the 802.11i incorporates National Institute of Standards and Technology Advanced Encryption Standard, AES, and uses a 168 bit key It provides a mechanism that is superior to the wired equivalent privacy used in internet virtual private circuits. You can see that. So it's very important for you to know when you are talking of, you know, privacy in your Wi-Fi, you start thinking of 802.11i standard. Also, you have the 802.11n and so on. So I say thank you for um, going through the self-tests in the engineering lecture series with me. Say it's going to be more regular from now on, that after lectures, 2 or 3 lectures in an area, we put up self-tests to see how one understood those, topics. So before I leave you, I will tell you that there is a saying, a baby hand is worth more than so in the bush. But I tend to disagree with that. That a bird in hand is still worth less than the other 20 in the bush. Enter the bush and hunt for more. So you are, you know, listening to engineering lecture series. Don't just listen to the ones that cover what you want to do. Look at the other ones and gain vast knowledge. If we look at the saying, if you use the effort you employed in getting the one bird you are having in hand and use it to go and hunt for the other 20 birds in the bush, you will see that you will catch more. So do not strive for less. Thank you for listening.